हरि करना।
Welcome to the first part of sixth module, which is Docker containerization, and the sixth module we call it as containerizing applications using Docker and Kubernetes. So this is the most important and widely sought application by the recruiter presently in the job market. It could be a DevOps engineer or MLOps engineer or a data scientist. If he goes with this tool, he will be selected as quick as possible because this is the widely used tool and it has a lot of demand at this moment presently in this market. So I would urge you to stay focused and put more effort and keep your attention level high so that you can follow up and you can clearly get everything what I'm talking about here in this Docker containerization. So I'm gonna take you through the theory first. At the same time, parallelly, I'm gonna take you through different exercises. So let's jump into the topics what we're gonna discuss in Docker containerization. So here we're gonna look into discovering Docker, how the Docker come up and so from where the Docker came, what is the history of Docker. Then after that we will look into the exploring the engine room of the Docker because we call it as a Docker engine. So that's the reason. So we will explore the Docker engine room. Then we will compare the Docker with the virtual machines. Then we will look into a lot of examples and the lot of commands that we use daily when you work on Docker. Then we will look into the configuration management and getting your house in order. It's nothing but stopping the container, removing the container, stopping the image, removing the image. So all this. So it's cleaning up. It's called a cleanup. It's house cleaning. And finally, we will look into the Docker Compose and Kubernetes in this first part. So then we will just have a glimpse of Kubernetes. Then we will look into the second part of the sixth module in depth about Kubernetes. And we will see a lot of examples meanwhile. So the question will begin with a question in discovering a Docker. So what is Docker? Why it is required? So what would it be if there was no Docker, if there is no Docker at all? How would it be? How this world would move? So there are a lot of questions, but there are no answers. If you know the answer, ping it on, ping it in comment section. I will look into that. Meanwhile, I will answer these questions one by one in this. If you want to know these answers, just follow me along this course. Okay. Now let us jump into the discovering the Docker and we will begin with what is a Docker. Docker is a platform that allows you to first build, then ship and run. So what I was saying, first build, then ship and run any app and anywhere. So this is the definition of Docker. I will repeat it again. Docker is a platform that allows you to first build, then ship and run any app anywhere. So it has come a long way in an incredibly short time and is now considered a standard way of solving one of the costliest aspects of software, that is deployment. So before we look into the hypothetical scenario that what would it be if there is no Docker, so let's understand what brings the what all the parameters that brings this differentiation between life before Docker and life after Docker. Okay, so the three parameters that we have considered here are inputs to the system requiring, and the maintenance that is required for the inputs, and then how many tools we require to configure the system, and basically to configure the systems and create an environments, and stages of software development, how many stages itself is required, and inside that stages how many inputs that you have to provide. So these are the three parameters we have taken to compare the life before Docker and life with Docker and hypothetical situation. So before Docker came along, the development pipeline typically consisted of combinations of various technologies for managing the movement of software such as virtual machines, configuration management tools such as Chef, Ansible, Puppet, SaltStack, and different package management systems, and complex webs of library dependencies. All these tools needed to be managed and maintained by specialist engineers, and most had their own unique ways of being configured. So what has changed after the Docker? So after the Docker, Docker has changed all of this, allowing different engineers involved in this process effectively speak only one language, that is a Docker language, making working together a breeze. Everything goes through a common pipeline to a single output that can be used on any target. There is no need to continue maintaining a bewildering array of tool configurations as you see on the screen at this moment. At the same time, there is no need to throw away your existing software stack. If it works for you, you can package it, and you can package it up in a Docker image, and then as you can consume it, or others also can consume the same thing as a bonus. It can be used anytime, anywhere, by anybody. That's what the Docker is. So if it is clear, it's fine, or else I will explain it one more time. I will with one example, the simplest example. So just to compare the life before Docker and life with Docker, so I'm going to take a simplest example. Let's take an example of web application, a simple static web application. Okay, so now we have to deploy this static web application. What are the processes that we follow? So we bring this, we develop the static web application. So web application source code is ready. So let me go back. Yeah. So now this is the condition. Web application source code is ready with us. Okay, now I will talk about a life before Docker, then I will move to life after Docker. So it should be this, the differentiation between life before Docker and life after Docker should be very clear before we jump into the actual Docker. So source code has been ready. Now what will we do? Once the source code is ready, then the configuration tools and provisioner tools like Terraform comes into the picture, Vagrant comes into the picture, and so once the tools has comes into the picture, so here we have three tools, that's Vagrant and Jenkins and Chef. We will use Vagrant to create a development virtual machine. This is a development server, and we'll use Jenkins or Ansible or some other tool for uh, conf for setting up a test server. Then, and we require a chef for a production server. So for one application, we cannot directly put that application into the production server. We have to, that application should pass through various servers, various stages, various environments. Begin with the development environment, then test environment, then a live or production environment. For that, to set up each environment at this moment, different configuration tools has been used. That is Vagrant for one, Jenkins for one, Chef for one. So each tool will have a different settings, different language, different templates, uh, different codes to be written. For Vagrant it is different, for Jenkins it's different, for Chef it is different. So that means you're literally dealing with a lot of tools, and as the inputs increases, the maintenance of this inputs also increases. That means it would be costlier, and as number of tools increases, the complexity increases, and then as the number of more environments and more configuration needs to be done, that means the 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 source code, the code that you write to configure these servers will also be complex. So there are a lot of complexity is involved in this. So how to deal this situation? So now then came a Docker. Let's see how this Docker deals with the same situation. Again, we take the source code, then we will need a configuration tool. At least one configuration tool is more than enough to set up a Docker server. So Docker server has been set up, and then either we can use a Jenkins as an automation server. So I am using Jenkins here. So now Jenkins, a configuration server, has configured and created and configured this Jenkins server. Inside the Jenkins server, we have also installed the Docker. Now this Jenkins server is gonna fetch. We have seen this example in our Jenkins module. So this Jenkins server is gonna fetch the source code, and once the source code has been fetched, Docker comes into the picture, and Docker will build the image using that source code with the source code. Then once your image is ready, then that same image can be deployed in development server, test server, live server. See the magic, man. See the magic. Here, every time you have to fetch the source code, and then you have to deploy it in different environment. Once, twice, thrice, every time, and the configuration with the each environment will vary a lot based on the tools. But here, in this case, logic is pretty simple. Jenkins comes into the action. It builds the using the Docker. It will build a Docker image. Once the Docker image is ready, now you just simply push that Docker image into every environment. That's it. See the differentiation. How much workforce, how much effort is reduced, and how much cost is reduced, how much time is reduced. Because of that, we have reducing the number of resources. Here, source code will be fetched to the Jenkins, and after that, as the thing is automated, the Jenkins will use Vagrant, Chef, Ansible, different tools to provision and configure the development environment, test environment, and live environment. Once it all developed, once the servers are ready, now it's time to push this code into each environment using package. Use the in package in .var format. So, but to push into each environment, it should be again configured specific to that environment. Whereas in Docker, it's simple. You build an image and you push it. That's it. That's it. I hope you got the difference. Now let's see what is Docker. To understand what Docker is, it's easier to start with a metaphor than a technical explanation. And the Docker metaphor is a powerful one. A Docker was a laborer. A Docker means a laborer. A Docker was a laborer who moved commercial goods into and out of the ship when they are at ports. So these are those laborers. You can see that laborers. These are the laborers. A docker means a laborer. A docker means a laborer who moved commercial goods into and out of ships when they docked at ports. So now there were boxes and items of differing sizes and shapes. An experienced dockerer, docker means a laborer, okay? An experienced dockers were prized for the ability to fit goods into the ships by hand in cost effective ways. Here also the same thing is happening. The docker, what it is doing is, the docker is fitting our applications in a cost effective way into a container. So that is the reason we are calling it as a docker. So what was there? What was done before? An experienced docker were prized for the ability to fit goods into ships by hand in most cost effective way. So here also the same thing. You have to fit your applications into your ships or into into your virtual machines containers in a cost effective way. So that's why we call it as a docker. So hiring people to move stuff around wasn't cheap, but there was no alternative at that time. From there this docker word has come. So this should sound familiar to anyone working in software. So much time and intellectual energy spent getting metaphorically odd shaped software into different sized metaphorical ships full of other odd shaped software. So they can be sold to users or business elsewhere. See, this is what the history of Docker, and this is what a Docker is.